Hello, chemistry students. Today we're going to be performing our molar mass of volatile liquid experiment. So in this lab, we're going to be determining the molar mass of an unknown volatile liquid using the ideal gas law. So let's get started. Okay, so the first thing we need to do is determine the pressure, which is 29.59 inches of mercury. Next, we need to take a 600 ml beaker, fill it most of the way with deionized water, and get it to boiling on a hot plate. I've also gone ahead and set up a utility clamp that we'll be using later. Then we need to take a 125 ml Erlenmeyer flask, make a foil lid, and poke one small hole in the top of the foil lid using a thumbtack. We will now determine the mass of the Erlenmeyer flask with the foil lid. So the mass of our 125 ml Erlenmeyer flask and the foil lid is 95.9330 grams. So the next thing we're going to do is we're going to add 2 to 3 milliliters of our unknown volatile liquid to our Erlenmeyer flask. So we're going to be using unknown volatile liquid D. We'll remove the foil lid. And add 2 to 3 milliliters of our volatile liquid to our Erlenmeyer flask. We'll replace the foil lid. And you can see that we have our volatile liquid in there. Now you can also see that our volatile liquid is dyed kind of a bluish color. Now the reason for that is I have gone ahead and added just a few milligrams of dithiazone dye, and what that's going to do is make it much easier for us to tell when there is no longer any volatile liquid remaining in the Erlenmeyer flask. Otherwise, the liquid is clear and it's very hard to tell. Okay, so the next thing we need to do is we actually need to take our Erlenmeyer flask and our volatile liquid, clamp it in our utility clamp, and then we're going to lower it into our boiling water so you can get about as much of the flask in the boiling water as possible. Okay, so now we need to monitor the volatile liquid in the Erlenmeyer flask. And that dithiazone dye is going to help us determine when there is no longer any volatile liquid remaining. Now for today's experiment, we're going to be assuming that the boiling water is exactly 100 degrees Celsius. You'll need that temperature and convert it to Kelvin for the ideal gas law. So we're just going to monitor the volatile liquid until there is no more remaining. The last drop is gone. This is going to take a little bit of time. As you can see, our volume is reducing of our volatile liquid. As soon as that last drop is no longer present, we're going to immediately pull the Erlenmeyer flask out of the boiling water. Just a little bit left. Almost there. Just a few drops left. And we are done. Okay. So we had our volatile liquid in the Erlenmeyer flask until no volatile liquid remained, and then I immediately pulled the Erlenmeyer flask out of the boiling water. We're now going to let this cool back down to room temperature, and we're going to dry it to make sure there's no water remaining on the outside of the flask. Okay, so we've allowed our 125 ml Erlenmeyer flask and the remaining condensed volatile liquid to cool to room temperature. So now we're going to determine the mass of our 125 ml Erlenmeyer, the foil lid, and the remaining condensed volatile liquid. Okay, so the mass of our 125 ml Erlenmeyer, the remaining condensed volatile liquid, and the foil lid is 96.0857 grams. Okay, so what we need to do now is determine the actual volume of our 125 ml Erlenmeyer flask. I've already gone ahead and disposed of our remaining condensed volatile liquid into the waste. So we're now going to fill to the top our Erlenmeyer flask with deionized water and then transfer that volume to a 250 ml graduated cylinder to determine the actual amount of volume that is in this flask. So we'll take off the lid, take our deionized water, fill our Erlenmeyer flask to the top. Just to the top. There we go. Now we're going to transfer this to the 250 ml graduated cylinder. There we go. So that is the final volume. That is the total volume of our 125 ml Erlenmeyer flask. You will need to use that in the ideal gas law to determine the number of moles. So now that we've determined the total volume of the 125 ml Erlenmeyer flask, you can use that in the ideal gas law to determine the number of moles. Now remember, you'll need to use the pressure that we took at the beginning of the experiment, and you'll need to convert that. You'll also need to use the 100 degrees Celsius temperature and convert that into Kelvin in the ideal gas law. Once you have your number of moles of volatile liquid, you can then use the mass of the volatile liquid, the remaining condensed volatile liquid that we got at the end of the experiment, and the number of moles to determine your molar mass of the volatile liquid. All right, so this concludes the molar mass of a volatile liquid experiment. Thank you for joining me.